This video is going to go over how our kidneys regulate water. And this process is going to be controlled by a hormone. But first, a couple things. So our bodies are constantly guarding against the loss of water. I mean, water isn't considered a nutrient, and yet it is essential to all of our cells' ability to function. So making sure that we have the right water levels in our body is a must-do process. We have to make sure that we're constantly doing this. So this process of regulating water and thus electrolyte movement into and out of the cells or the body is called osmoregulation. Remember, water moves in conjunction or at the same time that solutes move, so like sodium and chloride, potassium, okay? So when those electrolytes are moving across membranes, water is also moving. So water regulation and electroregulations are coupled together. Most of the osmoregulation that's going to take place and the adjustments to low levels or high levels of water are going to occur in the loop of Henle and in the collecting ducts of the nephrons. But we have to be constantly monitoring how much fluid level there is, and those are done by special receptors called osmoreceptors. And these are going to be specialized cells in the body that monitor the osmolality, so they're monitoring the solute concentration, like salt, in the blood. And so by monitoring the salt concentration, like I said, we can thus deduce how much water or fluid concentration there is. If you have a high solute concentration, you're going to have a lower water concentration, and vice versa. If you have a high water concentration, that means that you have less solutes or electrolytes floating in that water. So this is all going to be driven by a hormone called ADH, antidiuretic hormone. And this hormone is released by the pituitary gland. Its ultimate job is to concentrate the filtrate in the collecting ducts and in the distal convoluted tubule. So it's going to determine whether or not your urine is very concentrated, meaning there's less water in it, or whether or not it's really dilute, meaning that there's more water in it. And how it does this is that it opens channels within the collecting duct that will let water leave if needed. So for instance, if I am dehydrated, then ADH will open up channels in the collecting duct that will pull water out of the urine that's in there, out of the filtrate, back into my blood. And so then what happens will be that I will be urinating out a very concentrated urine because I've pulled water out of it to get put back into my body because the osmoregulators or receptors noticed that the levels were too low. So here's how this works. So we got osmoreceptors that are going to monitor the solute concentration in the blood. If they detect an increase in osmolality or an increase in solutes, so specifically focusing on sodium and chloride, so salt, it's going to trigger the pituitary gland to release the chemical ADH, the hormone, antidiuretic hormone. ADH will travel down through the blood and open aquaporins in the collecting duct that will allow water to be reabsorbed back into the interstitial fluid and the bloodstream. This is going to leave less water in the urine because we pulled it out. And so we will be urinating out a very concentrated amount of urine. Now, if there is no ADH release, so if the osmoreceptors don't recognize an increase in solute, or they recognize that everything is supposed to be where the levels where they should be, then no ADH is released and the collecting ducts will not release that water to the interstitial fluid, and it'll stay in the urine where it'll get excreted out when you urinate. So essentially, the absence of ADH will allow diluted urine to form, and the presence of ADH will cause concentrated urine to form because it's pulling the water out of it. So it's really a pretty simple process that involves all of those millions of nephrons, plus osmoreceptors, plus your brain with the pituitary gland and the release of ADH.